Well, hi, good evening. Thanks for joining me on the evening shift here while I continue work on this radio. And what I'm going to be focused on tonight is changing a few of the capacitors, the ones that are in the audio circuits of this radio. So I think we're going to start right off by having a look at the schematic. Okay, I think a couple of things that I want to take a look at before I really start changing parts is one of them is this voltage here, the 275 output from the power supply, and that actually sits right on the screens of the two output tubes. So I can actually look for it there, and for the plate should be just a touch lower because the supply is getting there through this coil, a bit of a resistance here. So it's 270, just a little bit lower. Another voltage I'd like to measure is voltage of the cathode. 23 volts is what it should be. That represents actually the bias of the tube. So it's using cathode biasing to control the tube. I guess I could say that. And the last thing is the grid. I'd like to measure the grid voltage relative to the chassis. Should say 0 on my meter, but it may not because this capacitor, and likewise down here, this capacitor could be leaking. And what's over here? The plate voltage of the audio amplifier here. So these are the blocking capacitors. And then I'll be on my way to changing all those and go just a little further over, probably this one, and probably this one. Just any of these that are bound to be the tubular wax type capacitors, just in the audio side of things, let's say beyond the volume control. Okay, just getting ready to make the voltage measurements. This set is not on yet, just sort of practicing in a way. So I can get the two B plus power supply voltages before and after the field coil here and here. Then I can get the voltage drop on the cathode resistor here. Then I can check the grids to make sure they're at 0. The grids are, I don't remember. The grids are just looking at the schematic, 5. So 5 would be 1, 2. This is why I practice. 1, 2, 3, 4, 5. This resistor here, 5, and that probably is the that's a 47 470K grid leak resistor right there. It's going to be the same thing over here, but a little tough to get to, but I have to get to it. So pin 5 over here, it's a little different. The tube is turned a bit. So 8, 7, 6, so 5 is here. 5 is here. There's an empty one there. Good. And cathode. I already did that. Cathode over here. Right. 4 tests. I'm ready. Okay, plug it in. Powering it up kind of first time on my bench here for a bit, so I'll keep our eyes on the lights. What do the lights say? The switch is off right now. The lights say all is good. Okay, so you can see this is the meter I'll be using. Ooh, scared me there. Okay, probably this kind of stuff may settle down once these capacitors all in this area get changed out. So the first one we'll do is the 2 capacitors. So expecting 275 and 355. 355 on one of those. Woo. Okay. I didn't know it was quite that high. So here we go. 355 over here would be all the way up to where my finger is. Scare me. There you are, 350. The yellow one then should be 275. Scare me there. Whoa, it's 400. Way high. Well, let's just check the line voltage here. 112. So go even higher. Okay, it is what it is. Now the next one we want to check is the cathode bias, which I'm expecting around 25 volts. So it should be about straight up. And we'll pick that up right here. There we are. It's right on. 28. Bang on. Perfect. The next one is to check for 0 volts on the 2 grids on the output tubes. That's pin number 5. Of course, this won't affect the volume. This might be a little noisy. And we're expecting this to not go up. 15 volt scale. We should not see that move. So 5 volt scale, that's got 2 volts positive on the grid. So we had 28 bias from the cathode resistor, and it's been reduced a couple by that. I think that's the way to look at it. Now the other grid is up in here. So I can't look, you tell me. So about half as much. But there. Okay, and then just to double check, we should probably look at the screen voltage on one of the output tubes. It'll be the same for both. And that's pin number 4. Okay, pin number 4, I'm expecting big whopping voltage there. 1, 2, 3, 4, that's this one. Big whopping voltage, 350 volts, and it's supposed to be 275. No way. No. It doesn't quite make sense. It doesn't quite make sense here. So right on the filter. Has this gone up? So it's that's 340. 400. So we're getting the lower voltage, as we should, showing up on the screen. It's just a wire going there. The higher voltage is more internal to the power supply. Much higher than, I don't know, should I just say congratulations to radio? You're really, after all these years. Not to worry about it too much though. Okay. So I think what might be interesting is to change the 2 grid capacitors and see if the grids sit at 0 after that. Yeah. That's what I'm going to do. Okay, the 2 capacitors I'm going after first here is this one, and this one. So this one's connected, pin 5, the grid of the output tube, the other output tube. Pin 5 is here, and this guy is connected there. Okay, I'll change those, see what happens.
just before I cut out the second one. So I've taken out the first one, which was down here, and look at it. That's a horror story. Sprague. Here's the other one. Doesn't look like it. Not made by the same company. It's kind of up in the air here, flying over. Replacement. I think this was replaced, but he didn't bother with this one. So this one may test better than this. We'll be testing these at some point. Nope. So sometimes you get these kind of fitted up, and then as soon as you apply the soldering iron, the solder melts. The stuff you fitted up against was nothing but solder. Well, actually, that's not so bad. I think I'm gonna redo it anyway. So as soon as the solder melts, it all comes apart. And you get a little bit of spring tension left in the wires, and you just go where they want to go. May not be where you want them. Same thing. Same thing happened. There we go. First capacitor done. This guy's next. .02. .01. Maybe they were being generous. I'm just going to take a peek at the schematic. So one is .01, the other one's .02. Okay. Oh, generosity. .02. That's a long ways. Okay, stick that one in. Okay, next thing we're going to do is we're going to test the two capacitors I've taken out. We're going to start with what I think is an original capacitor. One was leaking. One would appear to have been leaking a little more than the other. It strikes me that this one was the one that would have been the worst of the two. So this is quite interesting. Get a chance to kind of calibrate this test machine. I should turn it on. So this is going to put a DC voltage across this. Very simple test first and only. And the amount of current that leaks through it will affect this eye here. If significant current's leaking through it, the eye will be closed. Now when I first hit the test switch, the eye is going to slam shut because there's a big rush of current to charge the capacitor. But a moment later, all that's left is the trickle. The eye should, in a good capacitor of this size, this eye would pop open in a fraction of a second. Like that. Surprise to me. 150 volts. My gosh. This guy is testing really good. That is surprising to me. You just can't tell by the looks. Let's go a little higher. 250 volts. Still opening. Wow. You know, boy. Yeah, see, I didn't put money down on this. This might be charged a little bit. And that's a good thing because I would have lost out. Because for sure I would have bet it was bad. Now this one I would bet is not so bad. Because, you know, the looks can be deceiving. Let's get back down to 50 volts. What do you say? Okay, I don't think it's quite as good as the other one. 150 volts. It won't open. So isn't that surprising? What looks like a newer replacement capacitor, pretty sure that's true. Not as good as the older original. So surprising. Now, you could maybe reach the conclusion, wow, probably all the rest of these are okay too. Well, I don't know about probably. It's possible. They sure don't look it. They don't look special. Any others look replaced? Well, this has got a different name on it. It looks different. I could easily be wrong about that. They just bought their .02s from this company and their .01s from another company. Okay, it's time to try it again, and we'll see about those grid voltages. Here we go. Switch is off. Okay, we're on dim bulbs. Not plugged in. Okay, there we go, dim bulbs. Looks good. Okay, whoa, 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 whoa. You know, I saw this meter jump. Shouldn't jump like that. Not from a pop. I wouldn't think so anyway. Okay. Can't be sure what it is. 500 volts. No. So it was around 1.5 volts, wasn't it? Something like that, 1 volt. So we'll put this on a 5 volt scale to start with, and we'll check this grid here. I don't see the meter moving, so we'll make it 1.5 volts. Tiny movement. Okay, that's one, and the other one. Wait a second here. Oh, I'm looking on the wrong tube. Right here. Jump. Ah, what's happening there? I can actually see it climbing up. Well, another possibility is an open grid leak resistor. What would cause that to happen? So when we look in here, the capacitor's down there, the connections to this terminal, and this is the grid leak resistor. And this is a ground area right here, I believe. So this resistor could be open. Could be open. Let's just do that test again and see where we're at now. Okay, we'll check for that. Grid leak. So with the two new capacitors there, we can just put an ohm meter. And meter there. I could use this ohm meter. Why don't I do that? It's sitting right here. I think I almost never use the ohm meter here. Ohms adjust. Okay, so I don't know how accurate this is now. It wasn't too bad. Okay, taking a reading of the grid leak to ground. So that's, I think we would read that as, oh, R times 1. Come on, something really bad there. So we're expecting it to be 500,000. So it'd be like 50 times 10,000. 50 times 10,000, something like that. What happened to the 0? Yeah, this is why I don't use this, I guess. Didn't set the 0. Okay, now I think we are honestly ready to go. So once again, measuring that resistor. Well, so okay, so there's a reason why I don't use the ohm scale here. I've got to re-zero this again. Wasn't that exciting? That didn't get us anywhere at all. Let's go back to using Old Faithful here. Actually, it's not so faithful. 500,000. is what happens on the night shift. $500,000. Why would that voltage be there? The other one measures a little lower, but still $500,000. Wow, that's interesting. I couldn't begin to tell you why that might be high like that. Defective capacitor I just put in? I can't be the case. Brand new capacitors, newly manufactured capacitors. Okay, well, we won't worry about it for now because it's only a small amount against a fairly large cathode resistor generated voltage. Good. We should play this radio. Okay, let's see what we've got here. Oops. Not terribly successful. Okay, some heart attack. Nothing happens. Okay. That's good. I could inject some tube testing in here. Maybe I'll start off tomorrow with that. Okay. Why did I do that? I don't know. Thanks a lot for watching. And tomorrow evening I'll be back in here with it. See ya.